Welcome to Rges Algebra 1. This is Lesson 7A, and it will be covering sections 3.6 and 3.7 in your text. Now we're going now to properties of equality. Before, not very long ago, we talked about the field axioms. That would be things like the commutative property, the associative property, the distributive property. And if you do not know those by name, and remember what each one is speaking about, you will need that for this section. So go back and review that first. Now these are called the properties of equality. We have three axioms of equality. The first one is called the transitive property. And it simply says that, and by the way, all three of these begin with an if. Well, I guess the third one doesn't necessarily. Okay, it does not. So just these first two begin with an if, and that might help you. If x equals y and y equals z, then what do I know about the relationship between x and z? And all of you could probably fill this in for me, having never seen it before or knowing the term associated with it. If x equals y and y equals z, then I know that x equals z. Notice they're regarding axioms of equality because I'm using the equal sign. And they're axioms because they're difficult to actually prove, but they are very easy to understand. Okay, and so that's the first one, transitive property. I think students usually find that the easiest to remember, actually. The next one is called the, let's put the name first, the symmetric property, or the axiom of symmetry. And it simply says that if x equals y, then y equals x. Symmetry means they're the same on both sides of the body, bilateral symmetry, or we're the same in different sections, for instance, of an organism. So if the left side equals the right side, then the right side equals the left side. Okay, that's kind of what we're looking at there. And then the third one is what's called the reflexive property. And it's actually, these are almost in the opposite order as far as simplicity goes up, but this simply says x equals x. Now that seems almost absurd unless I think why I'm going to look at that. If I say 3x plus 20 equals x, it's telling me the reflexive property says that the x here and the x here equal the same thing. So, for instance, if I say simplify this, or solve this really because it has an equality, solve if x equals, well, I wouldn't say solve that way, but how do I want to explain this? Let's see, we'll be able to add these together, or if I am substituting in an expression, I would be able to add these two together because the x equals the same thing in both places. If I'm substituting when x equals 2, I would substitute the same value in both places. So all of that ideas that you've been working with already come out of this reflexive property. So you do want to know how to express them algebraically by these little sentences here, and you want to know their the wording, their title. Okay, so all of that needs to be learned. Now on the two more, that would be equations here. The addition property of equality. Says that if x equals y, then if I have a sentence, let's say x plus z, or a phrase, then I would be able to substitute the y in. every time I see the x equals y plus z. Okay, so I've substituted for the x, I've substituted the y. That's the additive property of equality. In other words, once I made that substitution, it's still equal. Okay. The multiplicative property of equality says a very similar thing. You could probably be guessing already what it says. It says if x equals y, then, now I'm going to be worried about multiplication, then x times z is going to be equal to what? I can substitute wherever I have the x, I can substitute the y, and so I can have y times z. So those are pretty straightforward. Now what's not so easy for students is when he takes these ideas then and he is showing you logic steps, so to speak, algebraic sequence of logic steps, and he's asking you to identify what rule allows me to go from step to step, either an axiom or property. Okay, so for instance, he has 15 equals 8 plus 2x, and then he has 8 plus 2x equals 15. Well, what has allowed me to go from there to there? To move this to the left side of the equation, and this part here to the right side of the equation. So that is symmetry. And so that's what he's asking, the symmetric axiom of equality. Okay, I'm just kind of doing the abbreviation. Now on the next step, he says 8 plus 2x plus negative 8 equals 15 plus negative 8. What allows me to do that? To add, what have I done? First off, you have to identify what you've done. What has changed from step 2 to step 3? I've introduced this on the left side and the right side. What allows me, what property allows me to introduce the same thing on the left side and the right side with my property of addition to not change the equality? And that is the additive property of equality. Okay. Okay, then for the next one, what are we doing? We have 2x plus 8 plus negative 8 equals 15 plus negative 8. And again, to solve this, what you have to do is you're comparing this line to this line, and you have to identify what is different. And this is where this student gets the most mixed up. I'm just looking at this, the third line and the fourth line. What have I changed? Well, I've changed this right here. I've changed the order of that. What allows me to change the order of two terms? The commutative property of addition. Okay, so I am going to let you step through his examples. He makes them very clear, but I just wanted to show you what you are doing. You're comparing that step with the next step, and the logic that allows you to do the second line from the first line, that's the reasoning. Okay, so now when this becomes the first line, this becomes the second line, whatever I write in here, the reasoning over to the right is what allows me to go from that step to that step. All right, so hopefully that's very clear. Follow through the logic very slowly. I will expect you to be able to name from examples all of these properties, or given the names of the properties, to be able to write an example. I will not ask you to do this step-by-step process on a test, but I think it's very important that you start learning how to do that. And so follow your logic and make sure you bring any questions to class for me. Now let's go on to the next section. Actually, the next section, 3.7, is the chapter review, and you will be turning that in, and I will be correcting that. I'm trying to look here. I want you to skip 31 So you don't have to bother doing that, but you will do 30. 30 is the easier of the two when we have that multi-step problem as I just showed you above. I really care about number 29, where it says write a statement of each. For instance, if I asked you write a statement that illustrates the commutative property of multiplication. This is just an example. Well, commutative means I change the order, so I could either do it with numbers. I'm asking for multiplication. 3 times 4 equals 4 times 3. I've changed the order. I didn't mean numbers. I've changed the order. I went 3, 4, then 4, 3. So that's commutative property of multiplication. Or I could write it in variables. X, Y equals Y, X. Your choice on how you illustrate it, but that's what he's asking for, to illustrate an example for each of the axioms or properties. Okay, I don't see anything else that should be too confusing for you, hopefully, at this point. And again, I will collect the chapter review. So don't worry about correcting it on your own. You don't have the answers for that. Okay. All right. Have a good time doing that, and we'll see you in class.